What if I told you the secret to lightning-fast compost isn't about adding more kitchen scraps, turning more frequently, or even buying expensive activators? You might be surprised to learn that the real solution lies in something so small you can't even see it with the naked eye. Today, we're pulling back the curtain on the hidden world that controls your compost's speed, a microscopic universe that holds the key to transforming your sluggish pile into a decomposition powerhouse. You've been there, haven't you? Standing over your compost bin month after month, wondering why your neighbor's pile seems to vanish into rich, dark soil while yours sits there like a stubborn monument to organic waste. You've followed all the traditional advice, added browns and greens, turned it occasionally, kept it somewhat moist, yet your compost moves at the pace of geological time. This frustration is more common than you might think, and it stems from a fundamental misunderstanding of what's actually happening in that pile. Most gardeners approach composting like a recipe. Add this, stir that, wait for results. But composting isn't cooking, it's farming. You're not just managing organic waste, you're cultivating an entire ecosystem of microscopic workers who determine whether your compost races toward completion or crawls along at a snail's pace. The real culprit behind your slow compost isn't what you think it is. It's not about having the wrong materials or insufficient turning. It's about the invisible workforce that does all the heavy lifting, and most of us are unknowingly creating working conditions that would make any labor union file a complaint. Picture your compost pile as a bustling factory floor, but instead of human workers, imagine billions of microscopic employees, bacteria, fungi, actinomyces, and other microorganisms, each with specialized jobs in the decomposition assembly line. Some break down proteins, others tackle cellulose, and still others handle the complex lignins in woody materials. When this microbial workforce operates efficiently, your compost can transform from kitchen scraps to garden gold in as little as 4 to 8 weeks. But here's where most composters go wrong. They focus on the raw materials instead of the working conditions for these microscopic employees. It's like expecting peak performance from factory workers in a building with no ventilation, inconsistent lighting, and an unreliable cafeteria. Your microbes have specific environmental needs, and when those needs aren't met, they slow down, go dormant, or worse, die off entirely. The concept of microbial diversity is crucial here. A healthy compost pile doesn't just need bacteria, it needs the right mix of different microbial species working in harmony. Think of it as an orchestra where each section plays a different part of the decomposition symphony. Bacteria excel at breaking down simple organic compounds and generating heat, while fungi specialize in decomposing woody materials and creating stable soil structure. Actinomyces, often called the ray fungi, handle the tough stuff like chitin and cellulose, giving finished compost its earthy smell. When your microbial community is out of balance or operating under poor conditions, the entire decomposition process slows to a crawl. Understanding this invisible workforce is the first step toward becoming the kind of composter who can speed dial their pile to maximum efficiency. Now that we understand who's really doing the work, let's explore how to create optimal working conditions for our microscopic employees. The first and most critical factor is what microbiologists call the carbon-to-nitrogen ratio, but I prefer to think of it as the microbe's balanced diet. Microbes need carbon for energy and nitrogen for protein synthesis and reproduction. The magic ratio is approximately 30 parts carbon to 1 part nitrogen by weight, though this translates to roughly 2 to 3 parts brown materials to 1 part green materials by volume in your compost bin. When this ratio is off, everything slows down. Too much carbon, and your microbes become sluggish from lack of protein building blocks. Too much nitrogen, and you create conditions that favor anaerobic bacteria, leading to that characteristic ammonia smell and slow decomposition. But here's something most composting guides don't tell you. The carbon-to-nitrogen ratio isn't static. As decomposition progresses, the ratio naturally shifts, which is why successful hot composting requires periodic adjustments. Fresh grass clippings might start with a CN ratio of 20 to 1, while dried leaves might be 60 to 1. Your job as a compost manager is to blend these materials to create the sweet spot where your microbial workforce thrives. Temperature is another critical speed dial factor, and it's intimately connected to microbial activity. Mesophilic bacteria work best at temperatures between 70 to 104 degrees Fahrenheit, while thermophilic bacteria, the speed demons of the compost world, operate optimally between 104 to 160 degrees Fahrenheit. The heat you feel in an active compost pile isn't just a byproduct of decomposition, it's a sign of intense microbial activity. When temperatures drop below 70 degrees Fahrenheit, microbial activity slows dramatically, which is why compost piles often stall during winter months. Moisture management might be the most misunderstood aspect of composting. Your microbes need water to function. They literally dissolve their food before consuming it, but they also need oxygen to maintain the aerobic conditions that drive rapid decomposition. The ideal moisture content is between 45 and 60%, which feels kind of like a wrung-out sponge. If things get too dry, microbial activity, well, it just grinds to a halt. On the other hand, if your pile is too wet, you end up creating anaerobic conditions that really slow decomposition and honestly can create some pretty unpleasant odor problems. Aeration is where, a lot of composters unknowingly sabotage their microbial workforce. Oxygen-loving aerobic bacteria are the real workhorses of fast composting, but they need consistent airflow to thrive. A compacted pile basically suffocates these beneficial microbes, letting slower anaerobic bacteria take over. This is why turning your compost isn't just about mixing materials. It's about keeping the oxygen supply going so your microbial factory can run at peak efficiency. The often overlooked factor of surface area dramatically affects how quickly things break down. Microbes work from the outside in, breaking down organic matter at the molecular level. When you chop kitchen scraps into smaller pieces or shred leaves before adding them to your pile, you're exponentially increasing the surface area available for microbial colonization. A whole apple might take months to decompose, while chopped apple pieces disappear in weeks because there's just so much more surface area for your microbes to work with. When your compost pile stalls, it's usually because one or more environmental factors have shifted outside the optimal range for microbial activity. A pile that's too dry will have dormant microbes just waiting for moisture to resume their work. You'll notice materials that look almost unchanged after months, especially woody items that really need consistent moisture for fungal breakdown. A pile that's too wet presents different symptoms. Anaerobic conditions create sour ammonia-like odors, and decomposition just slows down through a completely different bacterial pathway. The fix here involves adding dry brown materials to soak up that excess moisture and turning the pile to get oxygen back in there. Sometimes you'll need to temporarily remove soggy materials, let them dry a bit, then reintroduce them with better aeration. Temperature problems often show up as seasonal slowdowns, but they can also be a sign of moisture or aeration issues. If you've got a cold pile in summer, that's usually a signal you're low on nitrogen or moisture, while piles that never heat up might just lack a strong enough microbial population. The solution often involves adding fresh green materials or tossing in a handful of finished compost to inoculate the pile with active microbes. Compaction is honestly a silent killer of compost piles. Over time, materials settle and compress, creating anaerobic zones where beneficial bacteria just can't survive. Regular turning isn't just about mixing, it's about keeping that aerated structure so your microbial workforce can breathe. If turning isn't practical, you might want to add bulky brown materials like small twigs or corn stalks to create air pockets throughout the pile. pH imbalances can also slow down microbial activity. While most organic materials naturally keep things within the optimal pH range of 6 to 8, too many citrus peels, coffee grounds, or other acidic materials can make conditions tough for microbes. The fix is, balancing acidic inputs with alkaline materials like wood ash, or just making sure you have enough brown materials to buffer the pH naturally. Understanding your microbial allies does more than just speed up compost production, it transforms the quality of your finished product. When you optimize conditions for a diverse range of microbial activity, you end up with compost that's not just broken down organic matter, but a living ecosystem ready to boost your soil's biological activity. Fast, hot composting creates different microbial populations than slow, cool composting, and both have their place in garden management. Hot composting gives you nutrient-dense compost quickly and kills weed seeds and pathogens, while slower methods help preserve different beneficial organisms and give you more stable humus compounds. The microbes that thrive in your compost pile don't just disappear when you spread the finished product in your garden. They actually become part of your soil's living ecosystem. These beneficial organisms keep breaking down organic matter, suppress plant diseases, and form symbiotic relationships with plant roots to enhance nutrient uptake. In essence, every shovelful of microbially rich compost is, an inoculation of beneficial life for your soil. Mastering the microbial speed dial also makes you a more observant and, intuitive gardener. You start to notice the subtle signs that show how your compost ecosystem is functioning. The earthy smell of actinomycetes, the heat that active bacteria generate, and those white fungal threads that point to healthy decomposer populations. These observation skills transfer directly to understanding soil health in your garden beds. The journey from a frustrated composter to a microbial ecosystem manager represents a fundamental shift in how you approach garden fertility. Instead of just disposing of organic waste, you become a steward of soil life, creating conditions that support the invisible workforce sustaining all terrestrial ecosystems. Your compost pile becomes a kind of laboratory where you can observe and optimize natural processes that have been shaping our planet for billions of years. When you understand that composting is really about creating the best possible habitat for beneficial microorganisms, everything else just kind of falls into place. The ratios, the turning, the moisture management, all those traditional composting practices make perfect sense when you look at them through the lens of microbial ecology. You're not just making compost, you're cultivating life itself. Ready to revolutionize your composting game with this microbial knowledge? Go ahead and put these insights to work in your own pile and just watch the transformation happen. If this guide helped unlock the secrets of faster composting for you, hit that subscribe button and share this video with fellow gardeners who are still waiting for their slow piles to transform. Drop a comment below sharing your biggest composting breakthrough or challenge. I read every single one, and honestly, I love hearing about your garden victories. Together, we're building a community of gardeners who understand that the best gardens start with the smallest life forms.